Often, we want to factor a quadratic trinomial where the leading coefficient is 1, or at least in the case of homogeneous trinomials, the coefficient of one of the squared terms is 1. Let's look at what happens in that case. Notice that in general, the numbers that we used to split up the middle term, those don't appear in the factors. So once we split up the middle term, we still have to factor by grouping. But let's look what happens in the case where the leading coefficient is 1. So here I've got x squared minus 5x plus 6. My AC is 6. My B is negative 5. So I want to split 6 up as the product of two numbers whose sum is negative 5. After a little trial and error, negative 3 times negative 2 is 6. Negative 3 plus negative 2 is negative 5. And so I factor by grouping. My x squared and my 6 go in my corners. And then my middle term I'll split up as negative 3x times negative 2x. My first row, the greatest common factor is just x. I need an x in the first column, a negative 3 in the second, and then I need a negative 2 in the second row. Negative 2 times negative 3 really is positive 6. Oh, here, this factors as x minus 2 times x minus 3. And so what we notice is that these two numbers are the numbers that show up in the factors. Let's see if that was a fluke. We have x squared plus 4xy minus 12y squared. So our AC is negative 12. Our B is positive 4. And after a little bit of trial and error, we see that positive 6 times negative 2 is negative 12. And positive 6 plus negative 2 is positive 4. So when we factor by grouping, we have our first and last terms, x squared and negative 12y squared. And then we split up our middle term as 6xy minus 2xy. Greatest common factor in the first row is x. In the first column, I need an x. In the second, I need a 6y. In the second row, I need a negative 2y. And a negative 2y times a 6y does give me a negative 12y squared. My factors are x minus 2y times x plus 6y. And again, what we see is that the two numbers we found in the AC method, positive 6 and negative 2 in this case, are the same two numbers that appeared in our factors. This is going to happen whenever the leading coefficient is 1. And so whenever we'll have a 1 in our first row, first column, the numbers that show up in the factors are going to be the same numbers that split up the middle term. So that means that in the case where the leading coefficient is 1, we don't need to go through the whole AC method. Instead, we have this shortcut. So whenever we come across a quadratic trinomial that we want to factor, we should stop and say, is the leading coefficient 1? If so, I can use this shortcut. So in this example, we have 2x squared plus 5x minus 3. Of course, 2 is not 1, so we can't use the shortcut. We have our AC is 2 times negative 3 is -6. Our b is 5. With a little trial and error, we see that 6 times -1 is -6. 6 plus -1 is +5. And so we'll use 6 and -1 to split up the middle term. So our first and last terms are 2x squared and -3. Our middle term splits up as +6x minus 1x. First row, my greatest common factor is 2x. And then I need another x in the first column, a +3 in the second column, a -1 in the second row. -1 times 3 is -3. My 2x squared plus 5x minus 3 factors as 2x minus 1 times x plus 3. And notice that there's no 6 anywhere in my factored form. The numbers that I used to split up the middle term did not in this case appear in my factors. On the other hand, in this example, I have just one x squared, so I can use the shortcut. So I still need to at least think that my AC is -18 and my B is 3. So I need two numbers that multiply to -18, add up to +3. That'll be 6 times -3 is -18. 6 plus -3 is +3. There are my two numbers. Because the leading coefficient is 1, those are the two numbers that are going to show up in my factors. So my polynomial actually factors as x plus 6 times x minus 3. And we can check that that really works. X plus 6 times x minus 3 is x squared minus 3x plus 6x minus 18. Combining the like terms, that's x squared plus 3x minus 18, which is what we wanted. So leading coefficient 1, we can use this shortcut. Leading coefficient something other than 1, we need to use the full AC method.